number 24? 24 means ones, the number of ones in subnet mask. For example, you see here is 8 bits, here is 8 bits of ones, here is 8 bits of ones. So 8 plus 1 plus 8 plus 8, we have 24 bits. And if we take 1 here, so our subnet mask will be 255, 255, 255. And if we have here 1, so our subnet mask will be 128, 128. And in this case, this 24 will be 25. It means that we have 25 ones. So if we take this 1 bit, it means that we can divide this network in 2 subnets. If we take 2 in power of 1, we have 2 subnets. And these 2 subnets, 0 subnet starts from 1 to 126. This is the range which you can assign to the nodes on the network. 0 is dedicated for the network themselves, and 127 address is broadcast address in this subnet. So this is 0 subnet. And another subnet will start from the range 128. It's like 0 in this subnet. It's 128 is indicate the network themselves. So the range which you can assign to the nodes will be from 1 to 9 to 254. And the last one, 255, is broadcast. So if you take 1, we can define this like /26, because we take 26 ones. Yes, this is 8 bits, 8 ones, 8 ones, and 2 bits like ones. Yes, so we have 26 bits. And in this case, we have 4 subnets. It means 0, 1, 2, 3. And how can you find the range of nodes? You can use this formula. You can use 2, 8 minus z. And z is the number of bits you borrow from this part dedicated to nodes. So if we borrow 2 bits, it means we have 2, 8 minus 2, it will be 2, 6, yes, it is equal to 64. And this 64 means that starting from 0, the last is 63. Here will be 127, the last numbers. I'm writing here the last number. And here will be 1, how many? 91, and here will be 254. 5. Yes, 5. So the range in the first, in the 0 subnet will be from 1 to 62. This range you can give for nodes. For example, if we have router, here is our router, yes? Here is our switch, and we connect switch. We connect computers. One computer, A, B, C computer. And here we have another, for example, subnet. Yes, computer, for example, A. Go back. Keep. I will share again. Thinking. Share again. So in this case, For example, this will be, we can use IP addresses here from 0 subnet. Why I can write here? I see that we have only 1 minute left, so I suggest to disconnect and connect again, because the Zoom will disconnect us. Okay, where is my drawings? I see what my drawings, something disappeared. I will draw a new one. I will draw a new one. Okay, here. For example, we have here our router, here our switch, and here we have 3 computers. Yes. A, B, C. So we know what router divide or separate networks. So we need to have different network part for these networks. It means, for example, if we use here 192.168, for example, 1, and we can start from, for example, second IP address for this one. Yes, it will be 1.3 for this one and 1.4 for this one. Yes, and as I mentioned previous, you know what usually for routers, for gateways, we give first address or the last address in the subnet or in the network. So for router we give 1.1. Okay, but we can have in this part also IP addresses like this 6, for example, 1, and we can start from for example, from 65, for example, 65, and give this IP address for this computer. What it means? If we use default subnet mask like this, 255, 255, 2550, this configuration is bad. This IP addresses is bad because these computers is in the same network like these computers, because this part is the same. You see, this part is the same. But we can divide this network in subnets and separate these networks. For example, if we use subnet mask 192, you remember that we take 2 bits. It means what 8 minus 2 bits, we have 2 in power of 6, it means 64. So if we use this subnet mask, we can give IP addresses in this part from, for example, from 1 to 62. This is range of IP addresses to this part. Yes, and we can give for this part ranges from 65 to 126. This is ranges which we can give in this part, and because we use subnetting. Okay, why we can 64 we can't use, because this is indicated the network by himself, and 127 also can't be dedicated, can be given for exact node, for example, this computer, because this is broadcast, you remember. Okay. And what is another ranges that can be used? Another ranges, if you see 192, it means that we have 2 bits. So another ranges would be from 1 to 9 to 1 here, 192.290 because 191 will be broadcast and 128 is the network himself. Yes, and the last one will be 932.254, and 255 is broadcast and 192 is the network himself. If we write full IP address, it looks like, well, like this. This is indicate the network himself, and 192.168.1 193. This IP address can be given for network device. Okay, is it clear for you?
Yes, Professor. Thank you.
You understand this one?
Can you tell how to connect two routers? What should be the IP addresses?
Okay, if we want to connect this, because this router have two interfaces, yes, one interface is here, another here. So this router should have different IP addresses. So because here is different subnet here we have different subnet. So IP address in this place should be like 192.168.1 and can be start from the last one, for example. It can be the last IP address in the range. So in this range, the last IP address is 126. So we can give here 126. It's okay. And all computers in this part of network will communicate using IP ranges from 65 to 126. And if we want to communicate with this part, because we are using subnetting, so any IP address which is out of this range 65 126 will be transferred to another network through gateway. Okay, so
basically the subnetting is like separating this part of network from the rest of the network.
The idea of subnetting is to have more networks and less nodes in the network. Why? Because if we are using default subnet masks, for example, one in C classes, yes, in C classes. So we can have from 1 to 25, 4 different nodes in this network. But usually in one network, we do not have 200 computers. It's very big network, yes. Usually we have less computers in the network, and we want to separate this network. For example, we have one department. For example, IT department has, for example, 20 computers, and the accounting department have maybe 10 computers, and we want to separate these two networks, so we can use subnetting and divide this network separate. And why we want to separate networks? This is also related to security. If we separate networks, so the data from one network, for example, this switch is going only in this part of network, and this part of network won't be able to see what is going in this part. If we name, for example, this is A part, A subnet, this is B subnet. So everything what is going in A subnet, B subnet won't be able to see. So separating also increase our security. Okay, so the task for the next part of second laboratory is to finalize all tasks. I will share description of laboratories. Okay, here. So for first part, you should be already finished till 11, And the second part is you need to finish all tasks from 12 to final to 21. So you need to do this task. I suggest you to put more effort for this laboratory, because the defense, during the defense, I will give many tasks from this laboratory, because IP addressing is very important. This is like foundation. You need to know how to give subnetting, how to find sub classes of IP addresses, how to assign IP addresses for network parts. For example, you see here two computers connected with router, and we have some IP addresses, and you need to find some problems. What is bad in, for example, in this connection? What is bad in IP addressing? So you need very be good at this, because during defense I will give many tasks related with second laboratory. Okay, do we have questions about this?
I have a small question in the 11th question in this one.
11 here, yes?
Yes, just can you tell, I can tell the IP that I put to the router that gets the internet, and the IP that gets the router in the middle. What can those two IP addresses be? Just that's the question I had.
So this IP and this IP, it means that this IP should be from this subnet. Okay, I maybe do like this one. I take print screen of this picture, and we can open maybe Paint or some. I will open Paint. Put here and share another screen. Okay. For example, because we have here only 20 servers, yes, this is only 20 servers, so we can use, if we don't use here subnetting, because 11 tasks is not related with subnetting, we can give here the default networks. For example, for IT department, we can write 168, for example, 10, and from third computer to 22 computer, all IP addresses will be dedicated to these 20 computers. And here we can have 9, 168, 10, 1, 10, 1. Yes.
But I thought that this port is not normal computers, that they are servers, so they will have like the general address, which like the general port as the other computers as well, or they need to have separate ones.
We are talking not ports, I think. We are talking about IP addresses. All these computers is like separate nodes on the network, and every server should have own IP address, yes, to communicate with other computers, other servers. So here 168.10, it can be, for example, second IP address for this router, this interface. And subnet mask can be default 255.255.255.0. And gateway here, because gateway, it means that like path to the internet, yes. So the gateway for all these servers would be 192.168.10.1. it means the IP address of this router. So the traffic will go to the internet here from this router. And if we want to go to this network, so we need to add route. In every server, we can add additional route, which routes IP addresses to this network. So this part of network is different network. So we can take, for example, how many we have? 100, 150. It's also not very big, so we can use 192, 168, for example. If here we have 10, so we can use, for example, 11. 11 means different network if we are using default subnet mask. So, for example, the range, if we have 100 computers, we can take computers from, for example, we can take from 100 to 149. It's 100, it's 2. It means not 2 or 100, it's equal to, I will write 199. It means we have 100 computers, yes? So this range is for these computers. And for these computers, we can have range like 1, 2, 6, 8, 11. Here is 11 because it's the same network, yes? And the range will be, for example, from 200 to 249. Yes, the range is 50 computers. And the gateway.
It's the maximum number that can be in the last part of the IP address. Can you repeat that from last lecture?
IP address. Can you repeat your question?
Yeah, as you are writing the last part from like 200 to 249, right?
Yes.
What's the maximum number that can be written here?
It's 254. 254 is the maximum number because 255 is broadcast. Broadcast can be assigned to any node. So if you have 249, it's okay. It's everything okay because the last one is 254. Because it's 8 bits. 8-bit. We have 2 in power of 8. So it will be 256. Yes. But if we have 1, 1, 1, why we have 256 is from 0 to 55. It's combination. From 0 to 55, we have 256 combination. Or if we have all ones here, because for one part is 8 bits. You see, 8 bits. So 8 bits, it gives 255. It's the final number. Okay. So it is clear.
Perfect, sir. Thank you very much.
Okay, thank you. So if you have no additional questions, so we can finish today.
Sir, I have a question. In the 100 computers, you put from 100 till 199.
Yes.
And how did you put like from? I didn't understand the last part. How did you conclude that 100 to 199?
Because like, if we have from 1 to 10, we can have from 1 to 10. Yes. But if it starts from 0, 0 also is for 100. It's like from 0 to 9, because from 0 to 9 it's 10 numbers. You understand? Yes. If for example, I can start from 101, so I finished at 200. 200. But if I started from 0, so I finished 199.
Okay. Okay, understood. Thank you.
Yes. Okay, thank you for everyone, and We will meet next week.
Okay, Professor, thank you. Have a nice day.
Thank you.
Have a good vakar.
Gero vakaro. Ačiū.
Yes.